Now let's talk about reference angles and how to find them. So let's say if we have an angle of 120 degrees. What is the reference angle? So let's draw 120 degrees. 120 is in quadrant 2. So this is 120 relative to the positive x-axis. The reference angle is the angle between the x-axis and the terminal side, or the terminal ray, and it's always less than 90. It's between 0 and 90. So what is the angle here? To find that angle, we know it's, if this angle is 180 and this is 120, it has to be the difference between the two. So it's 180 minus 120. So this angle is 60. And that's the reference angle. So let's try another example. What is the reference angle for an angle that's 210 relative to positive x-axis? So this is 210. And we know the negative x-axis is 180. So the difference is 30. So the reference angle is always between a terminal ray and the x-axis. Now, there are some equations that you can use to easily find the reference angle. So anytime you have an angle in quadrant 1, the reference angle is equal to the angle in quadrant 1. If you have an angle in quadrant 2, the reference angle is going to be 180 minus the angle in quadrant 2. If the angle is in quadrant 3, the reference angle is going to be the angle in quadrant 3 minus 180. Now, if the angle is in quadrant 4, then it's going to be 360 minus the angle in quadrant 4. Try these two examples. Find the reference angle for 150 and also 315. So 150 is in quadrant 2. So this is 150. And to find the reference angle in quadrant 2, we can use this formula. It's going to be 180 minus the angle in quadrant 2, which is 150. And so the reference angle is 30. So 30 is between the negative x-axis and the terminal ray. Now, on the example on the right, for an angle of 315, that is in quadrant 4. And to find the reference angle in quadrant 4, it's 360 minus the angle in quadrant 4, which is 315. So that's going to be 45. Now, if you want to understand it visually, a full rotation is 360. And this is 315. So then this missing angle here is the difference between 360 and 315. So therefore, that's 45. And that's the reference angle. Now, what if you have a negative angle? For example, let's say negative 150 or negative 240. How can you find the reference angle? Well, if you don't want to do it graphically, the first thing you should do is find the coterminal angle. Negative 150 plus 360 is equal to 210. Now, 210, you know it's in quadrant 3. It's between 180 and 270. So to find the reference angle for an angle in quadrant 3, it's that angle minus 180. So the reference angle is going to be 30. Now let's analyze it graphically. So let's draw the angle at negative 150. So this is negative 90, and this will be negative 150. Keep in mind, negative angles you need to rotate in a clockwise direction. And we can clearly see that this angle has to be 30, because a straight line or a straight angle always add up to 180. So you can easily see the answer graphically. It's always the angle that's formed if you draw a triangle, or between the terminal side and the x-axis. Now let's try negative 240. So this is negative 90, negative 180, and here's negative 240. It's in quadrant 2. Let's find the coterminal angle. Let's add 360 to it. If we add 360, we get 120. So this angle is also equal to 120. And we know it's in quadrant 2, so the reference angle is going to be 180 minus the angle in quadrant 2, that's 120. This works if the angle is positive and between 0 and 360, the formulas that I've given you. So the reference angle is 60. And you can clearly see that this angle here is 60 between the x-axis and the blue line. Now what if we wanted to find the reference angle of an angle in radians? What can we do? So what is the reference angle of 2 pi over 3? It turns out that there's a nice and simple trick to find the reference angle. And it only works for common angles in a unit circle, like 4 pi over 3, 5 pi over 6, or 7 pi over 4. If you get some angle that's not on a unit circle, like 2 pi over 5, this technique doesn't work for it. So 2 pi over 3, 4 pi over 3, 5 pi over 3, negative 4 pi over 3, even 7 pi over 3. All of these, they share the same reference angle of pi over 3. Now, let's say if we have, for example, 5 pi over 4, or 3 pi over 4, or even negative 7 pi over 4, or negative 11 pi over 4. All of these, they share the same reference angle, pi over 4. 5 pi over 6, 7 pi over 6, 11 pi over 6, or even negative 7 pi over 6, or something more than 11 pi over 6, let's say 17 pi over 6. All of these common angles, they share the same reference angle of pi over 6. So if you see a common angle, you can literally see what the reference angle is going to be. Now, what if it's not a common angle? For example, let's say if we have 3 pi over 5. How can we find the reference angle for this? Now, you need to know what quadrant this angle is located in. And if you can't tell what quadrant it is just by looking at the way it is, I would recommend converting it to degrees first and do what you did before. So let's go ahead and do that. Let's multiply by 180 divided by pi. So we have 3 times, now 180 divided by 5 is 36. So this is 3 times 36. If we multiply that by 3, this is 108. So 108 is in quadrant 2. And to find the reference angle in quadrant 2, it's going to be the angle, it's going to be 180 minus the angle in quadrant 2. So in this case, 180 minus 108. So this will give us an angle of 72. Now let's convert 72 back into radians. So let's multiply by pi over 180. Now we know that 180 is 36 times 5. And 72 is 2 times 36. So we can cancel a 36. So 72 is equal to 2 pi over 5. So that is the reference angle. Now let's try some more examples. So let's say if we have an angle that's 9 pi divided by 8. Find the reference angle of this angle. So feel free to pause the video and work on it. So first, let's begin by converting it to degrees. So hopefully you have access to a calculator. 180 times 9 divided by 8 as a decimal is about 202.5. Now 202.5, this angle is in quadrant 3. It's between 180 and 270. So we need to use this formula to find a reference angle. It's going to be the angle in quadrant 3 minus 180. So therefore that's going to be 202.5 minus 180, which is about 22.5 degrees. So this is the reference angle in degrees. But now let's convert it back into radians because we was given an angle in radians to start with. So let's take this value and let's multiply it by pi divided by 180. Now what I would do is divide it backwards. 180 divided by 22.5 is 8. So you can view 180 as being 22.5 times 8. So you can cancel at 22.5. And so the reference angle is simply pi divided by 8. Let's try one more example, but an angle that is still in radians but has a negative value. So let's try negative 8 pi divided by 9. So let's multiply by 180 over pi to convert it to degrees. Now 180 divided by 9 is 20, and 20 times 8 is 160. So this is equal to negative 160. But now let's find the positive coterminal angle. So let's add 360 to it. 360 minus 160 is positive 200. And positive 200 can be found in quadrant 3. So now that we know we have an angle in quadrant 3, we can use this formula. It's going to be the angle in quadrant 3 minus 180. So in this case, that's 200 minus 180, which is 20. So 20 degrees is the reference angle. Now let's convert 20 back into radians. So let's multiply by pi divided by 180. So we can cancel a 0. And so we have 2 pi divided by 18. And 18 is 9 times 2. So we can cancel a 2. So therefore the reference angle turns out to be pi over 9. And so that's the answer for this example.